Our first speaker, I think you've all seen the bios, and I'll tell you, when I was reviewing it, I was very, very impressed. I won't read you the whole bio, but Jim Bruce, one thing I noted here, he assisted in the establishment of the Intergovernmental Panel on Climate Change, the IPCC, which we all now refer to and cite as the sort of authoritative voice on climate change. And subsequently was part of the IPCC delegation, which received the Nobel Peace Prize in Oslo, which is a pretty big honor to so he's an officer of the Order of Canada, and the list goes on, and I think we're incredibly privileged to have Jim Bruce here with us, and thank you very much for coming.
Thank you. I think I'll try to stand. It doesn't make much difference whether I'm standing or sitting. And it is a great privilege to be able to have a chance to talk to you about climate change science. And I'll give you a fairly quick overview of the science and the way it's been developing. And here's, whoops, that doesn't work.
Too far away from me.
That one? No, doesn't seem to go.
Maybe you have to have that.
Yeah, that's it.
It might be too far.
Yeah. Can I call to you to get?
Yeah. Sure. Yeah.
Yeah. Okay. Okay. This is a graph which shows the 400,000 year history of carbon dioxide and methane in the atmosphere. Carbon dioxide's in blue and methane's in red. And you can see that over the 400,000 years it sort of cycled back and forth along the, from 400,000 years ago up to the present, or near the present. Never went above about 280 parts per million. And it seemed to have a natural limit there. And in those periods, it was somewhat warmer on Earth. In the places where the carbon dioxide was low, somewhat cooler. And you can see that methane sort of fluctuated in a similar kind of way. Human ingenuity has been such that we're now up to, instead of the prehistoric or the pre-industrial revolution figure of 280 parts per million, we're now up to about 380, and if we don't do something about it, we may end up at 1100 in the next century. So it's remarkable how much human activity has changed the chemical composition of the Earth's atmosphere. And at the same time, the methane has gone up, and it will continue to go up as our wetlands and muskeg areas melt and methane comes back from those areas. Next one, please. There's always an argument about whether human activities have caused the changing climate we've seen in the last little while, or whether it's been mostly natural forcing factors, like changes in the amount of sun's energy reaching the Earth because of sunspots or because of the rotation of the Earth, or volcanic emissions. And this is an important analysis that was published in the Intergovernmental Panel on Climate Change 2007. The blue band are the temperatures that you would expect from the natural forcing, external forcing factors, the sun's energy change and volcanic emissions and so on. And the red band is the band you would expect from greenhouse gas forcing. And the black line is the actual observed mean temperature. The big one is for North America, and there's a global and a global land down below. They all show about the same thing. And it's quite interesting that up till about 1970, you can see that the mid-60s, 1970, you can see that the natural forcing factors, the changes in the Earth's rotation, the changes in the sun reaching the Earth, were very important in changing the global mean temperature. But since about 1970, the trajectory of global mean temperature has been exactly what you would expect from the greenhouse forcing of the climate. Those skeptics who say, well, it's all due to natural factors that forcing the climate, we've always had it, were right up to about 1970. But since 1970, we've seen a very rapid change in the Earth's mean temperature, and it's due almost exclusively to the greenhouse gases. Next one, please. This is a plot of this is to sort of look ahead a little bit. The bottom thing here is a plot of all the emission scenarios that the IPCC and scientists around the world have used to estimate what future climate is likely to be, going from 2000 on the left up to 2100. And these are emissions of greenhouse gases, not concentrations in the atmosphere. That previous one was concentrations in the atmosphere. These are emissions due to human activities. Mainly fossil fuel emissions, but partly from deforestation. And you can see there's a range of estimates put forward based on estimates of future economic growth, future populations, and future energy mixes. And the only trouble is that the actual increase in emissions has been much closer to the dash line. In other words, the International Energy Agency in 2007 said that the world's energy needs is going to go up 55% by 2030, and without some strong and urgent action, we'll have a 57% increase in GHG emissions and a 27% increase if we really had accomplished something at Copenhagen, but we didn't. So we're in for a continuing rapid increase in emissions of the greenhouse gases, the carbon dioxide and methane. I should mention that the theory that the Earth would warm with the increase in carbon dioxide in the atmosphere is a very old one. It goes back to Fourier and Arrhenius in the 1800s. And this is a well-established physical theory. The sad part of it is that human actions have made it proven that the theory is correct. Next one, please. Because of this increased emission rate that we've seen, some of the projections from the IPCC and other sources like National Center for Atmospheric Research in the United States, the blue band is the drop in the amount of ice at the end of the summer, September, in the Arctic. And that blue band is what the models projected, and the red is what's actually been observed, and it's continued to go down. So that because the emissions are going up more rapidly than any of the IPCC projections, the things in the atmosphere and in the factors affected by the atmosphere are changing more rapidly than even the most pessimistic projections of the IPCC. And this is just one example. Next one, please.